Welcome to the June 2024. This is the Edexcel GCSE. This is paper 3H of the 1MA1 series. Okay, highest common factor. You can list factors of 63 and 105 if you want. It shouldn't take you too long. I'm going to do prime factor decomposition. So 63 is equal to 3 squared times 7. 105 is equal to 3 times 5 times 7. And then I'm looking for the factors they have in common. They both have a 3 and they both have a 7. So the highest common factor is 3 times 7, which is 21. Question 2, that's 53,000. And then at 0.00074, 4 zeros after the decimal place. And then carrying out the addition, 3.42 times 10 to the 7. Okay, looking at it from the side, it's not going to be 4 centimeters high. So the height of the rectangle that we have there on the view is too high, definitely. Then to draw the plan view, so it's the view from the top. We've got a base of 7. And we've got a height of 6, and we've got to draw the roof bit, the bit running across the top through the middle. To increase by 6% 3 times by 1.06 to the power of 3. Find the total number of workers, 29,775.4. Don't think we can have 0.4 of a worker, so I'm going to just leave that as 29,775. Question number 5. We have Habib with his identical tins. Dividing by the density allows us to work out the volume. So 600 divided by 0.6 is 1,000. Subtract 700 from that gives us 300. Divide the 600 by the 300, we get 2 grams per centimeters cubed. For the probability, 0.6, we need to add 0.4 to that to make it 1. For the second row, we're adding 0.45 each time to make it 1. And then heads and heads is 0.6 times 0.55, which comes out as 0.33 for that one. For the paddling pool, it tells us that its radius is 100 and its height is 30, so we can work out its volume, pi r squared h, pi times 100 squared times 30 is 300,000 pi. So that's the volume. Dividing that by the 250 centimeters cubed per second gives us 1,200 pi seconds to fill. We want to turn that into minutes, so I'm going to divide by 60. So we get 20 pi minutes. And 20 times pi comes out as 62.83, etc., etc. So to the nearest minute, that's 63 minutes. Two lots of A plus 1 lot of B, that's 2 lots of 3 over 2 plus minus 1 over 4 is 5, 8. So we need a vector that goes 5 places to the right and 8 places up. So as long as you pick somewhere low enough in the bottom left, count 5 to the right, count 8 places up, join them up, there's your vector 2A plus B. Question number 9, we've got ourselves a cube, so it's a 6 by 6 by 6 cube, so the volume of it will be 6 cubed, which is 216. For the volume of a pyramid, 1/3 times the base area times the height, 1/3 times 8 squared times h. And we know that those two are the same. So 1/3 times 8 squared is 64 times h is equal to 216. So h will be equal to 216 divided by 1/3 of 64. You can type it into your calculator like that if you wish. It comes out as 10.125 centimetres. Okay, for the counters in the bag, if we have X red counters, then we can work out an expression for the number of yellow counters. It would be 5 over 3x because they're in the ratio of 3 to 5. So the number of counters in bag A will be x plus 5 over 3 lots of x. Well, x is the same as 3 over 3 lots of x, so that gives me a total of 8 over 3 lots of x. The number of counters in bag B is half that, so that would be 4 over 3 lots of x. And so the total number of counters in both bags, let's add 8 over 3 lots of x and 4 over 3 lots of x, which will be 12 over 3 lots of x, simplifies to 4x, which was what the question wanted. Okay, for Mina and her speed recordings, you can work out where the upper quartile and the largest value are from the interquartile range, etc. It should look like that once you're done. Then you've got to compare the median and you've got to compare the interquartile range. So the median speed on Sunday is higher than the median speed on Friday. And the interquartile range on Sunday is higher than the interquartile range on Friday. And then therefore, missing an E at the end of therefore, the data is more spread out on the Sunday. So on Sunday it's got a higher median and there's more spread out data. Alright, so for question 12, this is a stretch scale factor -2, centered at the origin. So I'm going to draw a line from each of the vertices going through the origin where it's twice as long on the opposite side, and then join up the points to get my new shape. I called it T prime. Question 13, well, 30 times 29, different combinations. We'll divide that by 2 so we don't double up. 435 ways. Okay, for question 14, I'm going to reverse it step by step. So working backwards, I'm going to add 1,000 to reverse the £1,000 Kim took out. And then I'm going to divide by 1.035, that reverses the 3.5% interest. That's 3,804. Then I'm going to add 750, that reverses the £750 that was taken out. And then I'm going to divide by 1.035 again to reverse the interest that was earned. And that shows us that Kim invested £4,400 at the very start. Question 15, cancel an A minus 3, so we're left with an A minus 3 and just the 5 at the bottom. Factorising, 3k minus 1, k plus 4. Then for C, to simplify that fraction fully, I'm going to factorise as much as I can. So difference of two squares factorisation, 2 plus x, 2 minus x. The denominator factorises to x times x plus 3. Then I'm going to flip the fraction and multiply. So multiply by x plus 3 over x plus 2. And there's loads of stuff that will cancel. So cancel the x plus 3s, cancel the x plus 2s. And we're left with 2 minus x over x. We can do no further cancelling there. Question 16, plugging -3 into the function, it's 12 over -3 plus 1, which is 12 over -2, which is -6. And then for B, you can construct f of g of x and plug 1 in. I think it's easier to just calculate g of 1, take the output, and then plug that into f. So g of 1 is 2, f of 2 is 4, so the answer is 4. G inverse of 4, if we equate g to 4 and solve it, we can find the value of x. I've added 3x to both sides, subtract 4 from both sides, divide by 3, so that is a third. X is a third. Okay, H1, it tells us is 8. To find H2, we multiply 8 by 0.55, which comes out as 4.4. To find H3, we multiply 4 by 4.4 by 0.55, which gives us 2.42. And to find H4, that's the height after the fourth bounce, we multiply by 0.55 again, this time 2.42. Comes out as 1.331 for the answer for that one. Alright, question 18 is the trig question. So it tells us the area of ABC is 54. We can use that to work out AC as the first step. So half AB sine C, a half times 17 times our length AC times by sine of the angle between them. Sine of 35 is equal to 54. So to find AC, we can divide 54 by the other stuff around AC. A half times 15 times sine of 35, and AC comes out as 11.1. Try not to round during a question here. Then I'm going to use the sine rule on the triangle ACD. So AD divided by sine 48 will be equal to the 11.1 we've just calculated, divided by sine of 57. We're going to multiply both sides of that equation by sine of 48. So A to D will be 11.1 times sine 48 over sine 57. Again, use the answer function on your calculator to avoid rounding. A to D comes out as 9.81. If you have to round at some point, do it to a load of decimal places, and that way it gives you enough accuracy to get the correct answer at the end. Then to find the area of ACD, we'll use half AB sine C again, so half times 11.1 times 9.81 times by sine of the angle between them. That's the one we don't know, so sine of 180 subtract 48, subtract 57, and that comes out as 52.5 square centimetres if you've rounded correctly. For 19, the upper and lower bounds question. So the upper bound of P is going to be 5.885 times 10 to the 8. The lower bound of P will be 5.875 times 10 to the 8. The upper bound of Q will be 3.65 times 10 to the 5. And the lower bound of Q will be 3.55 times 10 to the 5. Then we want to find the lower bound of R. To find the lower bound of R, we want P to be as small as possible and Q to be as large as possible. So we'll take the lower bound of P and the upper bound of Q. The lower bound of P, 5.875 times 10 to the 8. The upper bound of Q, 3.65 times 10 to the 5. And that comes out as 1,609.589, etc., etc., etc. Rounded to the nearest integer is 1610. For an arithmetic series, for an arithmetic sequence even, the common difference is always the same. The difference between the first and the second term and the difference between the second and the third term is the same. So if we subtract the second term from the first term and subtract the first term from the second term and subtract the second term from the third term, they'll be the same. It allows us to construct an equation, solve the equation, and we'll get x to be 7/2. Then for a geometric sequence, we have a common ratio. So if we divide the second term by the first term, we'll get the same as what we get if we divide the third term by the second term. so the two r's if you like. That would be equal. It gives us a fractional equation to solve. Multiply both sides by y plus 2 and multiply both sides by y minus 4. And then expand everything out. So y plus 2 squared expands to y squared plus 4y plus 4. And the right hand side expands to 3y squared minus 11y minus 4. Then I'm going to collect all the terms on the right hand side. Subtract to y squared, subtract to 4y, subtract to 4. And factorise. Well, you can use the formula if you wish. Y equals negative a half or 8. Those are the two answers for that one. Alright, question 21. I love this question. Seriously good question. Right, I'm going to call the lengths little r for the smaller hexagon and the lengths capital R for the larger hexagon. It's regular, so they're all the same. I'm going to draw in myself a little right angle triangle just up there. I could have drawn that anywhere from a vertex to the centre. We know it's going to be 30 degrees. It's 1/12 of 360, or 60 degrees because it's half the interior angle of a hexagon, whichever rationale you wanted to use, you can do. Okay, so the perimeter of the larger hexagon will be all the capital R's added together, 6 R's. The perimeter of the smaller hexagon will be all the little r's added together, that's 6 lots of little r. And the circumference of a circle that's in between them both will be 2 pi times little r. The radius of the circle is going to be the same as little r. You can see that as it runs round. Okay, doing a bit of trig on the right angle triangle, I can show it so cos of 30 will be equal to little r over big R. So our little r will be equal to big R cos 30. Cos 30 is root 3 over 2, so let's divide both sides by cos 30. Let's divide both sides by root 3 over 2. We get big R is equal to little r divided by root 3 over 2. Or if you prefer, 2 lots of little r over 3. I've rationalised the denominator there, so 2 root 3 over 3 lots of little r. So those three lengths can form our inequality. So the little hexagon is less than the circumference is less than the big hexagon. I'm going to replace capital R with 2 root 3 over 3 lots of little r. And 6 times 2 root 3 over 3 is the same as 4 root 3. 6 over 3 is 2, of course. And at this point we can divide everything by r. And at last halve everything, and we get 3 is less than pi is less than 2 root 3. Gives us bounded version of pi there from a geometric construction. Well done if you got that. Really enjoyed that question. Okay, all right, bye.